Introducing Test View window in Distance Room Part 1. As mentioned before, one of the windows of Distance Room is Test View. This window consists of 6 tabs of Shot Test, Check Test, Search Test, Setting, Trigger, and Binary Output. In Shot Test tab, it is possible to specify fault type and test point, and after performing the test, you can view the results of the evaluation. In Test Point section, in this tab, the test point can be specified using 2 methods. First, the impedance magnitude is entered in Z field in terms of ohm, and in phi field, the impedance angle is entered in terms of degree. Then, by clicking on Add, the values are entered and the software displayed in the real and imaginary values of this impedance in R and X fields respectively. In the second method, it is possible to directly enter the real and imaginary values in R and X fields, and by selecting Add, select your intended point. If you wish to enter your test point in terms of percentage of length of the line, you should use percentage field. By checking Z relative option, the test point is made of dependent on the length of the line and recorded in the table. By changing the length of the line from 1 to 3 ohms in Test Object section, in Distance Parameters window in System Settings, the entered impedance value is changed in accordance with the length of the line. But if this option is not checked, by changing the length of the line, the entered values in the table do not change. In fact, each test point consists of 3 states which simulate pre-fault, fault, and post-fault states. By default, in pre-fault, fault, and post-fault, 0 nominal voltage and current, 0 voltage and current, and a voltage and a current based on the test point are injected respectively. To change pre-fault and post-fault states, you should use Setting tab and Time section. More explanation about this section will be provided in setting videos. Just note that if PT connection is wired as at bus bar, in post-fault, the 0 current and nominal voltage will be available. The fault type is specified in Fault Type section. These faults include phase to ground, 2-phase, and 3-phase faults. Before specifying the fault type and fault current, it is necessary to select the test model from among fixed current, fixed voltage, and fixed resource impedance. In fixed current model, the injection current is fixed and the voltage changes in accordance with the test impedance. In fixed voltage model, the test voltage is fixed and the fault current changes in accordance with the test impedance. In fixed resource impedance method, the resource impedance includes the impedance from the origin to fault plus the impedance of ground to the fault point, angle, and the grounding factor. By selecting Add, the selected test point is added to the table in this window. By selecting any of the rows and clicking on Insert option, the selected row is repeated in the table, and by clicking on Remove, the selected point is removed. By selecting Add to option, it is possible to copy the point or points selected for one of the fault types to another fault type. By selecting Remove All option, it is possible to remove all of the test points added to the table. By clicking on Sequence option, Sequence Test Points to page opens, where it is possible to create test points with equal steps. By selecting Angle in a Step 1 field in a Step section, the angular steps are directly entered in terms of degrees. This means that the test points are specified according to the origin point entered in Origin section in a way that the required angles result in proportion to the horizon. For example, if the start and end angles equal 45 and 90 degrees with 5 degrees as their steps, and the origin points are entered for Z and phi or R and X. After selecting 5 ohms as impedance and 36 degrees as the origin, and by applying these settings, you can see that multiple points are added on the impedance view. For example, the last point is selected. You can see that the resulted angle is 85 degrees, not 90 degrees. This happens because the origin point is also considered as one of the points. But by selecting direction, an angle is specified in Angle field, where from the origin point with the length entered in Length field and with the steps specified in a step size, some points are shot on the characteristic curve. Note that the length and the steps of the points are in the forms of ohms. For example, if the angle is 45 degrees, the length is 5, the step size is 0.5 ohm, and the origin point is 0 ohm. By applying these settings, you can see that some points are created in 45 degrees with zero origin in impedance view. Note that in both the states of angle and direction, it is possible to make the origin dependent on the length of the line and specify it in form of a percentage of it in Z relative section. If the performed test has failed points, by selecting Clear All Failed Test option, it is possible to clear the results of all these points. In Details section, the information related to trip nominal time, the allowed operation time range, actual time, and test point evaluation are entered in tnom, tmin, tmax, tact, and stage fields respectively. The test points are entered with detail in the table at the bottom of the page. The details include test evaluation, test current, nominal time, operation time, fault value in terms of percentage and seconds, and the minimum and maximum operation time. Also, if you wish to add a comment about any of the test points, you can use the user comment cell. At the bottom of the page, it is possible to select test points table from different fault types. To test, a point is shot in L1E fault type. By using Add to option, this point is also added to L1, L2 and L1, L2, L3 fault types. Note that if L1E option remains checked, the point added for the L1E fault type will be repeated in this fault type. Then open the Signal View window and run the test. You can see how the voltage and current signals are injected for every test point. After testing each point, its evaluation is recorded in the table as well as the impedance view.